Hello, my name is Shiwei Zhou. This is my poster, Texture Transformer Image Super Resolution for Computed Tomography. To improve the spatial resolution and to suppress noise of low-dose CT images, we adapted a texture transformer network. The TTSR is a reference-based image resolution method. We adapted to translate low-dose image to full-dose CT images. The low-dose images and full-dose images are served as a query key in this transformer. The network is component with the three different components: texture extraction, relevance embedding, and adaptation-based texture transform, and synthesis. Then we will test with two different data. The first one is from the X-Phantom generated simulated data. The second one is the patient data. The performance will much more better by using the TTSR. Okay. Let's go induction. X-ray is widely used image in the radiotherapy, but since it's the ionizing radiation, it will be much more harmful. So we want to reduce the dose. To reduce the dose, we may have some low resolution and high resolution part. For low resolution, the detector size will be larger, and thus less pixels. And high resolution would be a smaller detector pixel size, lead to high resolution. So we want to keep the resolution high and the low low. Here's how we design the network. The first red part is the input part, and the yellow part is for the network, and the blue one is for the output. We'll compare three different methods: the cubic spline, the traditional numerical method, and the ground circle is what we proposed last time to generate the images. And the third one is what we proposed here. It's to improve the resolution. Then the evaluation criteria will be three different ways. The first one, the overall image quality. The second and third are for the PSR and SSM is matching values. For the simulation, we will use the 4DX phantom to generate the several phantom images. Then noise-free phantom images will be added with the several noise, the Poisson distribution noise and normal distribution noise. The Poisson distribution noise will be added with the two different levels to simulate for the full dose and no dose. Then we will compare with the three different reference images. For the image part, we are directly reconstructed from the projection using the conjugated distance square, and then train the network from scratch instead of what we pre-trained. Let's go to the network part, network result part. The first one is the full dose one. It's clear, yeah, that's the baseline. And the second one is for the cubic spline interpolation. It's much more blurry. And third one is for the cycle gain output. It has some detail, but it's still blurry. And the second row is for the different TTS reference input. The first one is input with the random reference, and second one is the partial aligned reference, and third one is the totally aligned reference. We can see the totally aligned reference has the best metric result and the best image result, but the difference are tiny. And for the patient part, we will only use the partial line since it's much more possible to obtain the data. Okay, so let's go to the patient part. The first line is full dose, the second one is low dose. You can see the low dose has much more strict artifacts. And then the second row, the first one is for the GAN circle output. It's much more blurry. Yeah, you can see here. And then the TTS output, it has much more better than the TT. TTS is much more better than the GAN circle, and it's clear and much more detailed. Okay, that's the conclusion. Here we developed a texture transformer to improve low-dose image quality. The TTSR-based transformer is a really good one compared with the other methods. So we can both achieve the high image resolution and low dose. Yeah. Thank you.